Guys, once again, welcome to Lali Seduho, and I'm very excited to be here to deliver another exciting and an educational video. I really hope you enjoyed my previous video on how to map with QGIS, and I hope you've practiced them. If you have not subscribed to the channel, please do subscribe, share, and comment. And most importantly, make sure you hit that notification button. So anytime I release a video, you will be the first to see it. So what do I have today? Today we are going to talk about remote sensing and GIS. This is one interesting topic. Geographers like myself are interested in. So we are interested in what remote sensing is and its application or what it can be used for. So in the delivery, we are going to talk about what remote sensing is. We'll talk about the electromagnetic spectrum, the spectral bands, the image types, and how images are formed with the image bands. So remote sensing is the art and science of obtaining information about an object or phenomenon through analysis of data that is obtained by a device that is not in contact with the object or phenomenon. This is a very nice definition, and you can classify this definition into three parts. It says is the art and science of obtaining information about an object, which is the second one, through analysis of data, which is obtained by a device. Wow. So when we say art, what is an art? Art is basically um, the method of creating something in the form of a picture, something catchy, illustrative, in order to catch your reader's attention. And science is basically the method of gaining knowledge through observation and drawing conclusions. So the combination of these two to study about a phenomena. Wow. So in remote sensing, our object of study or our phenomena is the planet Earth or the universe. So Earth. So in remote sensing, we are basically interested in the study of the Earth. Through analysis of data that is obtained by a device. What is this device? This device is what we call the sensor or the remote sensor. So this device, you can classify it into two types. You have the satellite remote sensing and the imagery remote sensing or the photograph. That is, the sensor is being carried on a platform like an aircraft, helicopter, or a drone. So let's move on. As you can see this diagram here, it explains the processes involved in remote sensing. So let's go through these images we have here. The lights we have here doesn't represent the light in your house. It represents the solar energy or the sun. And the arrows we have here represent radiation or electromagnetic radiation. Hence, in order for remote sensing to work, there needs to be a presence of the sun. So the sun is the main source of electromagnetic radiation. So we have the atmosphere, what we have here from this section, and you can see before the electromagnetic radiation reaches the Earth's surface, it is intercepted by the atmosphere, where part of the electromagnetic radiation is reflected, refracted, scattered, and incident. And what we have here is our sensor. So I would say this is a satellite remote sensor. And this sensor, what it does is it captures these reflected energy. So the sensor captures the reflected energy that is incident on the object we have here. So let's assume this is the Earth's surface, or this what we have here is a vegetation. When the light rays is incident on this, it is reflected, and this reflected energy is being captured by the remote sensor, and this reflected image is being processed and stored in form of what we call the channel or the bands, and saved in the form of a pixel. So as you can see here, the box we have here, each box is a pixel containing information. And the last one we have here is the atmospheric correction. The atmospheric correction also is a different topic altogether, but let me just give you a summary of what the atmospheric correction talks about. In remote sensing, there's something we call noise, and noise is any distortion or any error that comes when we are processing or analyzing an image. And this geometric errors is caused by many factors. It could be from the sensor, it could be from the platform, it could be the topography of the land, it could be the rotation of the earth. As time goes on, we are going to take a very critical look at each of these features. Hence, it is corrected, and some of the methods we use in correction, we normally classify it as pre-processing or image pre-processing. And the most common ones are the calibration, the geometric correction, where we have the rectification and the registration. We also have the radiometric enhancement. We have the spectral enhancement and the spatial enhancement. So let's deal with this for now and let's move on. So remote sensing. Most of remote sensing uses the electromagnetic spectrum. The human vision system is a remote sensing system that operates in a small portion of the spectrum. Though scientific remote sensors are similar to human vision, they have capabilities that are well beyond that of humans. So, in case you still do not understand what remote sensing is, just picture your eyes in your minds. What am I trying to say? The remote sensing works like the human eyes, in a sense that the human eye is able to see a plant and say, oh, this is green. It sees this color and identifies it as red. It sees this and identifies it as blue. It sees a color and identifies it as black. That is basically what the remote sensing does. However, the remote sensing is more enhanced than that of the human because it is able to see beyond that of human vision. So the remote sensing can see or can sense things like electromagnetic radiation. We have the gamma rays, it can sense gamma rays, it can sense beta waves, it can sense microwaves, it can sense infrared, it can sense ultraviolet rays, but the human eyes cannot see or sense these. So this is why remote sensing is has capabilities more than that of the human eyes. So what we have here, electromagnetic radiation is indicated by two fields. We have the electricity and the magnetic fields, and these two are perpendicular to each other. So as you can see here, electromagnetic radiation, electricity, and magnetic. So this is the definition we have here. And here it says in remote sensing, the main source of electromagnetic radiation is the sun. So as I made earlier on, we need the sun in order to get reflected energy to process what we want to study. So this is the types of electromagnetic waves we have here. We have the gamma rays, the X-rays, the ultraviolet, infrared, microwaves. And these waves are categorized under their wavelengths. So microwave, their wavelength is very shorter. So as you can see, followed by the X-rays, also is also in the short wave radiation. We have the ultraviolet, also between the short and long wave radiation, and from the infrared all down to the microwaves and the radio waves. You can see they are in the long um, wavelength. They are in the long wavelength. So let's move on. So how does this work? As I explained earlier, we talked about how the electromagnetic radiation works based on the diagram we saw earlier. So electromagnetic radiation or electromagnetic energy, that is the sunlight, is incident on an object and reflected. The reflected energy is transmitted up to a sensor. This sensor captures that available energy, what we call the radiance. Signal is quantized into a discrete value and put into a pixel known as the gray value. The gray value is processed into a visualized the gray value is processed and visualized on a display or put into an image product. So this is what we have here. We have the sun. This is our object, and the sun reflects energy on this object, and this reflected energy is being captured by the remote sensor and it's being quantized into a pixel, and it's gone through an image product where we have the geometric corrections as well. So the next we have here is the spectral bands. Images are also stored as a raster and have more than one band. That is, we have the panchromatic and the monochromatic images. And the panchromatic, they have just a single band. And the multispectral bands too, they have two or more bands. But mostly when displaying an image, the display monitor has just three channels. That is the red, green, and the blue. So with multispectral imagery, you can only display three bands at a time. So what we have here, this is the multispectral. We have the band 1, which is blue. It mostly ranges from 0.43 to 0.5, where we have the green band 2, which is band 2, ranges from 0.5. We have the band 3, and we have the hyperspectral band 2. They have many colors, so as the name suggests, hyper. And we also have um the panchromatic, which we said earlier on, it has just one color. So let's look at this image we have here. We have image A and we have image B. So which of these images do you think is panchromatic or multispectral or hyperspectral? So 5, 4, 3, 2, 1. Which one did you identify as panchromatic? Is it A or B? Well, image A is a panchromatic image because from what I can see, unless I'm color blind, I can identify just one color band, that is black. And for B, I can identify as many colors, so we can say this is a hyperspectral or a multispectral band because it displays three or more colors. We can identify yellow, blue, green, and what have you. So this is the bands, the wavelength, and the importance. So the band 1, which is blue, it ranges from 0.45 to 0.52 and is used for bathymetric mapping. Bathymetric is simply deep ocean mapping, and it distinguishes soil from vegetation and deciduous from coniferous vegetations. We also have the band 2, which is the green, and it ranges from 0.52 to 0.60, emphasizes peak vegetation, which is useful for assessing plant vigor. What this means is the remote sensor is able to identify which vegetation is more healthy and which vegetation is less healthy or not healthy. The red band also used for discriminate vegetation slopes, and also you can add to it the red band also is used to identify man-made features like roads, schools, buildings, cars, what have you. We also have the band 4, which is the near infrared, which ranges from 0.7 to 0.9. It also emphasizes on biomes. So it is advisable you learn these for the purposes of exams. And those of you want to further, when an image is given, you should be able to describe that image based on the bands and the color without um, making reference. What is band one? What is its wavelength? All these things should be on your fingertips. So now we are coming to the end of this wonderful tutorial with the importance of remote sensing. So remote sensing, remote sensing, remote sensing. Let me just give an adapt. In remote sensing, as we mentioned earlier on, we said we have the satellite imagery and the aircraft imagery. One advantage of the aircraft imagery is it is um, it is able to view just a smaller portion of the Earth's surface or the object of study, but it gives a very high spectral resolution. When I say resolution, it's just the brightness or sharpness of an image. And then we also have the satellite imagery, and because of their distance, they are placed above the atmosphere, they are able to see a relatively larger area. Hence, its resolution is very coarse, or it's not as visible as that of the aircraft image because of the distance. So, like the maps, you see sometimes whilst you keep zooming, it becomes very blurred. That is an example of the satellite imagery. So what do we have here? It says large area coverage. Remote sensing allows large coverage of a very large area, which enables regional survey on a variety of themes and identification of large features. So, as you all know, the current situation in Russia and Ukraine, if one wants to study the areas affected with the war, it is not necessary to go there and pick your data. By remote sensing, you can either opt in for the satellite, which is very expensive, or you can just use a drone or an aircraft and just take the information you need and analyze it yourself without having going there yourself. And remote sensing also allows repetitive coverage, which comes in handy when collecting data on dynamic themes such as water, agriculture, fields, and so on. So mostly the satellite imagery, it takes coverages repetitive. So because of its positions, it takes coverage for day one, day two, day three, day four, day five, day six, and so on. So this enables you to make some distinctions. Oh, so this vegetation was like this for this particular time range, but after some time it started diminishing, and after some times it started reproducing again. So it helps you, it allows you take a repetitive coverage of your object of study. So these are the importance of remote sensing. You can write them down for the purpose of exams. Those of you like to study, and those of you who are interested in remote sensing. So, guys, you have finally come to an end of this wonderful session, and this is just a summary of what remote sensing entails. In my next video, we are going to go into details. We'll talk about the various errors in image acquisition, the pre-processing methods, the calibration, the geometric corrections. We'll talk about how the remote sensing actually works. We'll also talk about the electromagnetic spectrum, what it entails, what the atmospheric window is, what the remote sensing captures, and the importance of the remote sensing. So guys, thank you very much for watching. I do hope you find this video educative. Please make sure you subscribe and hit that notification button. Thank you very much. Bye bye.